Ever wonder how self-driving cars really see the world? It's not just about cameras or sensors, it's about collaboration. Today, we're diving into cutting-edge research that's redefining how vehicles and systems work together to understand their environment. Let's break down the science behind this smart teamwork. First, let's talk about multi-agent perception. The idea that vehicles, drones, or even traffic systems can share information to get a clearer picture of their surroundings. Imagine one car spotting a pedestrian around a corner, then instantly sharing that data with nearby vehicles. That's the future we're building toward. But how do we train these systems? A lot of the work relies on pre-training, a process where models learn general skills from vast amounts of data before tackling specific tasks. For example, researchers are using synthetic driving data to teach models how to predict trajectories or detect objects. This is super important because real-world data is expensive and hard to collect. Now here's where things get really cool. Some teams are using self-supervised learning, a method where models learn by solving puzzles in the data itself. Take BEV-MAE or TMA, for instance. These techniques hide parts of sensor data, like LiDAR point clouds, and train the model to reconstruct them. It's like teaching a robot to guess a missing puzzle piece based on the ones it sees. This approach reduces reliance on labeled data, making training faster and more efficient. Another key area is collaborative perception. Papers like V2X-Sim and V2X-Real introduce datasets that simulate how vehicles share information. Think of it as a digital playground, where researchers test how well systems can combine data from multiple sources. For example, one vehicle might share its view of a road, while another adds its own perspective, creating a 360-degree awareness that's way more accurate than any single sensor could provide. But collaboration isn't without challenges. Researchers are tackling issues like asynchrony, when data from different sources arrives at different times, and misalignment, where sensors from different vehicles don't perfectly match. Techniques like Agentalign and Core aim to fix these problems, ensuring that shared data is reliable and usable. So what's the big takeaway? The future of autonomous systems isn't just about individual intelligence, it's about collective smarts. By training models to learn from each other and adapt to complex environments, we're one step closer to safer, smarter roads. But how do we scale this? Let's zoom in on a breakthrough, TurboTrain. This method tackles the core challenge of training AI to handle multiple tasks simultaneously, like a soccer player mastering dribbling, passing, and saving goals without one skill undermining the others. Traditional approaches either overload the system or force it to learn step by step, which is slow and fragile. TurboTrain changes the game. Here's how it works. First, mask reconstruction. Picture this: you're teaching a child to recognize a puzzle by covering parts of it and asking them to guess the missing pieces. TurboTrain does something similar with sensor data. It hides parts of what the car sees, like LiDAR points or camera images, and trains the AI to rebuild them. This helps the system grasp the structure of the world, where objects are, how they move, and how different sensors see things, without needing perfect labels. It's like giving the AI a head start by letting it explore the data on its own. Then there's gradient balancing. Think of it as a referee in a team sport, making sure no single task, like object detection, drowns out another, like predicting where a pedestrian will step. TurboTrain's conflict-suppressing system keeps all the tasks in harmony, so the AI learns everything smoothly. The proof: TurboTrain outperforms older methods by nearly 2% in predicting vehicle paths on complex datasets. It's like giving self-driving cars a sharper vision and a better brain for planning. And it works even when data is incomplete, critical for real-world chaos like construction zones or bad weather. This isn't just about faster cars, it's about safer, smarter systems that can handle the unpredictable. Next time you see a self-driving car, remember, it's not just seeing the road. It's reading the future, learning from its peers, and getting ready to revolutionize how we move. Imagine a self-driving car gliding through a bustling city. It's not just reacting to what's in front of it, it's anticipating the dance of traffic, the sudden jaywalker, the brake lights ahead. But here's the secret: this car isn't learning in a vacuum. It's part of a team, sharing insights with other vehicles and getting smarter every second.